Hello, this is Jonas from VHDLwhiz.com. In this video, I'm going to walk you through the process of installing the iCEcube2 design software from Lattice on Ubuntu Linux. And I'm also going to show you how you can program the iCEstick FPGA development board from Ubuntu Linux. iCEcube2 design software comes in a Linux version and a Windows version, but the Linux version only works out of the box on Red Hat based systems like CentOS. It doesn't work out of the box on Ubuntu, but we can make some changes and install some dependencies, and then we can make it work. And I'm going to show you exactly how to do this in this tutorial. And by the way, the blog post that I'm using in this tutorial, I'm going to link to this blog post from the description in the video. So go to the video description and click the link that will take you to this blog post that explains everything and also lists the commands. So this recipe, which lists all of the commands that I'm going to enter, I'm actually going to just copy paste from this listing and paste it into the command line on Ubuntu. So you can do the same on your system. Just go to the video description and click the link to get to this blog post. And the first thing you have to do is to download the iCEcube2 design software. There's a link here in the blog post, iCEcube2 design software, and this is the page. Just click software, downloads and documentation, and click the Linux version. And when you do that, you will have to create a free Lattice account, and downloading this software is free, and you will have to request a license later, but you have to create an account and just click this link and go through the whole process. I have already done that, so I am ready to install, and I have created a new virtual machine with a fresh install of Ubuntu 20.04. So this is the latest version of Ubuntu 20.04 at the moment, and there's nothing installed on this system. I have only installed Linux and updated the packages. So I'm going to go into my home folder, which is empty apart from these default folders. And I'm going to copy the iCEcube2 installation file into my home folder, like this. And the next thing I'm going to do is to right click and select Open in Terminal, which brings up a command shell. And we see now, if I do an ls, that we have the installation file here, the tarball. The first thing that we are going to do is to update the system. So just copy these lines, apt update, apt upgrade, paste them into the terminal. You will have to type your sudo password the first time you do this, and it didn't work for some reason. Let me just paste that in again. And there we go. Everything is updated because I did this just moments ago to keep this video short and easy. The next thing you have to do is to install the 32-bit dependencies. So these are dependencies that the iCEcube2 installer need to install iCEcube. And I have found this by using the apt-file command, so apt-file search. And these are all the ones that I needed to install. So if you need to install some other dependencies, if the iCEcube installer is going to complain, then I recommend using the apt-file search command and enter the file that the iCEcube2 installer is complaining about. But I have done this already and found that these are all of the dependencies that we need. So just copy this one. Start by doing this anyway. Paste it in like this. Do you want to continue? Yes. So now we are installing all of the 32-bit dependencies. Well, actually there's one dependency that we are not installing because I had some trouble. And the next dependency is also a 32 dependency, the libpng. I wasn't able to install this automatically because it's not available in the repository for apt, and if I download the package for this one, the deb file, it's not going to work because there's something wrong with the install paths inside of this package. It's an outdated package, but we need it to install iCEcube2. So what I have done is to include a version of this file that I found on the iCEcube2 forum, and there's a link down here to the forum somewhere here. If you go down here, you can see the Ubuntu answer here for the guy that created this package. And I'm not going to talk a lot about this, but it is a package that somebody else created. So if you are reluctant to install this package that you are downloading from my server, the VHDLwhiz server, then at the end of this video, after we have installed iCEcube, I'm going to show you how you can verify that this package is actually safe to install and that I haven't changed any of the files. I'm going to show you how you can verify for yourself that this package is unchanged, that only the installation paths are changed. But for now, I'm going to trust myself and download the package using wget and install it. So just copy these lines and paste it in here, like this. So now we have installed all of the dependencies, and the next thing we need to do is to change the default Ethernet name in Ubuntu, but change the grub config or the bootloader config. So the problem now is that if I type IP link show, in the new version of Ubuntu, the default Ethernet name is ENS33, and it's not ETH0 like this. ETH0 has been the default name for a long time, but for some reason it's now changed to ENS33. And this doesn't work with the iCEcube installer because the iCEcube installer depends on reading the Ethernet name like this, ETH0, because it node locks the license, the free license that you're going to request. It is node locked to the MAC address. And unfortunately, this ETH0 is hard coded inside of iCEcube2. And the only way to fix this that I have found is to actually change the Ethernet name in Ubuntu. So we're going to do that. And the first thing I'm going to do is to make a copy of a backup of the grub config. No, not this one, but this one. Sudo copy grub to the grub original file. So I'm pasting this one in, and now we made a copy of the original grub config, the bootloader config. To fix the Ethernet name, to change it, we're going to copy these lines that are going to change some of the config in the file. So now I pasted in the lines. I'm going to the next line here in my recipe and copying the diff, because we're going to make a diff between them and see that the correct lines have changed. So after you paste it in my lines, the SCD command that changes the lines, so this is an alternative to editing it manually. I don't like editing, I like scripts. So these are the changes. The new grub config contains some words here that are not in the original one. So this line has become a bit longer, and that's what my command just did. So just make the diff and verify that this is what you are seeing when you do that. And now we are done with changing the Ethernet name, but before it will take effect, we will have to reboot and update the grub config and reboot. So just update the bootloader, copy these files, these commands, copy these commands, update grub and reboot, paste them in like this. Okay, so there my virtual machine has rebooted. And I'm going to go into my home folder again when the desktop is going to show. So go into my home folder, and we're going to right click and select open in terminal so we can continue like this. And the next step now, I'm going to copy this IP link show, because we're going to verify that the Ethernet name has now changed. And there we see the Ethernet is no longer ENS33, it's named ETH0, and that is enough to satisfy iCEcube2. So the next thing we're going to do is to install iCEcube2. So I'm going to copy these lines that will unpack iCEcube and make it executable and run the installer. Let's just do that now. And I'm in my home folder still, so we're going to install iCEcube in the user space and not as root. We're going to install it in the home folder. I'm just going to click next and go with all of the defaults, accept the license agreement, install it to the default directory, which is LSCC in my home folder, so home Jonas LSCC, that is semiconductor, I guess. It asks about the license, but we're going to skip it for now. We don't need to enter a license quite yet. And it's going to ask if I want to launch iCEcube2, and let's just do that so we can see this error. License checkout failed because we didn't specify the license file. But before we are done with the installation, I'm going to change some of the files in the iCEcube installation directory, because iCEcube depends on or uses the bin shell like this. I'm going to do a grep for just to show you the problem now. For bin sh in the Lattice installation directory. Just do this recursively. You can see all of the occurrences. So, in a lot of scripts, it uses bin sh, but this is a different bin sh shell from the one that's in Ubuntu, because in Red Hat this one behaves differently than in Ubuntu. And the way to fix this is to change all of the occurrences here from bin sh to bin bash, which is the default shell in Ubuntu. And we're not going to do this manually because I have created some lines here, command lines that will do this. So I'll copy these command lines, which will do all of the replacing for us. Just copy these lines. And I'm going to do now again the grep. We can see that there are only a few places left, and these are in documentation, and this is actually not a match, this is something else. And they have been changed now successfully to bin bash, just like that. And then we are ready to start iCEcube2, because if you didn't do this, you're going to get some error later on when you try to synthesize. It's only in a troubleshooting section of this blog post, but if you do this beforehand, you're not going to get into trouble. So I'm going to right click and copy this command to start iCEcube2. It's in the installation folder in iCEcube2. There's an executable named iCEcube2, and this is the one that we can use to start the program, like this. But we still have the license checkout failed, like this, because we haven't specified the license file. And what we need to do now is to request the license. And to request the license, you need to have the MAC address of your Ethernet 0 network adapter. So in the blog post, I'm listing this, or describing how we can get this by using the IP link show command. So we're going to do that just now. It's in the same spot as the iCEcube executable. Oh, sorry, that's the license manager. Type IP link show like this. And we have our Ethernet 0 adapter here, and I'm going to copy this, which is the MAC address. These 12 digits, copy them. And then we're going to go to the Lattice iCEcube license request form. You can find a link in my blog post. It's a free license, and I have already downloaded it now. If you have never downloaded it, then you have to go through this again and create an account. Just paste in the MAC address, but you need to replace the colons with dashes like this. And click verify and generate the license. But I have already done this, and I have received the email from Lattice let me see. When you do that, you're going to receive an email like this with your license.dat file. And I have already downloaded the license file, so I'm going to go into my installation directory, lscc, Lattice installation directory, and just paste in the license file like this. So we have the license file right there. And then, as I stated in my blog post, the next thing we need to do is to run the license setup. Just copy this line. Back in my terminal, the license setup is a program in the installation directory. And now we can click browse to the license in the installation directory, the license in that file. Okay. And now we are ready to run. So we can go back to the iCEcube2 command and run it like this. And just to make sure that it works, I'm going to open one of my projects. So I'm going to go to my file manager once more, go back to my home folder, and I have the project from my fast track VHDL course, the fast track VHDL course for beginners. And this is the one you get when you sign up for the fast track course. And I'm going to right click and extract this file with all of the Lattice, all of the VHDL files and the Lattice project. So I'm just using this as an example now, the project from the fast track course, so that we can see that it's going to work in Lattice, that the Lattice software is actually working. And I'm going to click here, open, to open the project, and browse to my home directory in the seg7 folder, in the implementation folder. In there you will find the project file to open. And the next thing that we're going to do is to go to tools, to run all, and run through the synthesis. Now the synthesis is running. So if we didn't do the replacing in the files with a binsh and with binbash, then we would be getting some errors right now. But since we fixed everything from before, it succeeded, and the bitstream has been generated. So that is that's great. It looks like Lattice iCEcube2 is working nicely. Now, how do we get this this bit file which was generated? How do we get it onto the FPGA? The standard Lattice tool, if we go to the past the troubleshooting section, so I'm at the blog post now, I'm going past the troubleshooting section, and we're going to look at this Lattice Diamond Programmer Alternative. So the standard program from Lattice is this one, Diamond Programmer, to program the FPGA, but this one is difficult to get working on Red Hat Linux. I mean, it works on Red Hat Linux, but it's difficult to get working on Ubuntu because it depends on outdated versions of the libusb library. So a much better alternative is to just use the package from project IceStorm. So it's very simple. In standard Ubuntu, just copy this line, sudo apt install FPGA IceStorm, copy it into the command line. I'll make a new command line actually, because I'm already running iCEcube in one of them. Paste it in like this, sudo apt install FPGA IceStorm. Yes to install. And there you go. So what we're going to do now is to use the iceprog command to program the FPGA, and it has a help menu, but it's really simple. You just type iceprog and the path to the binary file. So I have now plugged in my iCEstick FPGA board, and I'm going to do it just as it says in my blog post, just specify the path to the binary file, and it's in my seg7 folder, the project folder, in the implementation folder, in the seg7 implementation folder there. So this is the iCEcube2 folder, sbt, outputs, bitmap, top bitmap.bin. Now I have plugged in my iCEstick board, and I'm going to hit enter now. Oh, wait a minute. This is the virtual machine, so I'm going to check that actually the device is plugged in, and it's not. So this is a virtual machine, so I'm just going to connect my USB device, just like that. And now when I press enter, I see the lights flashing on my FPGA board. And keep in mind, I haven't installed any drivers or anything. Everything just works out of the box with this iceprog command. And it's programming the FPGA. And there you go, the programming has completed and everything is working. We can see that the digits on the 7-segment display are counting. So this is the project from the Fast Track VHDL course, and now you have the tools to do it also on Linux. So that was actually the complete tutorial for how you can install iCEcube and how you can program the Lattice iCEstick FPGA board from Ubuntu. So you can stop now, but I promised you that I was going to show you how you can verify that this package that you downloaded from using this command, that it is safe to install. And to do that, I'm going to download the original package. So we already have the modified package here. This one, libpng. So I'm going to download the original package now, and I have a link in my blog post to it, so let's go find it. Here's the missing libpng section in the troubleshooting section. So here's the modified package and the link to the original package. So I'm just going to copy this link and paste it in here. So you can see the link comes from Ubuntu.com. So this is not from somewhere you cannot trust. This from Ubuntu repository. So if I paste this one in, it's going to download the original package, and then in the I'm going to paste in the package now. Just grab it and paste it in there, and we're going to unpack both of the packages. So the package, that's the original package, and the one that I have modified, or that's modified, extract it here, and we're going to open the files. Let me see. Something crashed right now. Let's see. Right click, open in the terminal. And now we have both the libpng folders right here. We have the modified one, which is called 1B, and the unmodified one, which is downloaded from Ubuntu. So what I'm going to do is to unpack all of the files inside of there. Let's go inside of here and unpack these files. Extract here. And delete the originals. So I'm going into the extracted deb folders and extracting all of the files so that we can compare them. Just like that. And what I'm going to do is to make a list of all of the files in the original of the MD5 sums. Find by using this find command. I'm going to get the MD5 checksum for all of the files and place it in list number 1, like this. Then I'm going to do the same for the modified version. Place it in list number 2, list B. And we're going to make a diff of the list by using meld list A and list B. Meld is not installed, so we have to install it. This is a fresh installation of Ubuntu, as I said. So let's just go through that and install meld. So all of this is just for ensuring you that this package is safe to install and enabling you to verify this from your own computer. So if we make the difference between the two packages, we can see that the MD5 sum file is changed. That's because the paths are changed, and this file is changed. But I think this one and this one is the same actually. So I'm going to reorganize one of the files, list B. Just reorganize the file. I'll take this line and move it to the top so we can compare the files that are actually the same. Okay, so we see here the MD5 sum of the MD5 sum file is changed because this path is changed. But all of the other files, they have the same MD5 sum. So that means that they are unchanged. The only thing that is changed is this file, this path to this file. And that's what we had to do to make it work in Ubuntu Linux. So that's the method for verifying for you that the modified version of the package that you can download from the VHDLwhiz.com website is legit. But if you just trust me, then you can just go through the whole of this recipe and download it by using this command. And that is all. So I hope you have now the tools that you need to install the Lattice software and make it work on Ubuntu and start developing FPGAs on Ubuntu. I will also recommend my other video, how to make ModelSim work on Ubuntu 20.04. So if you do these two recipes, these two walkthroughs of how you can install ModelSim and how you can install iCEcube2, then you are ready to start developing FPGAs on Ubuntu, and you can do my fast track course and you can do my advanced.matrix course. So that's all for this video. Thank you for watching and stay safe.